What's an ellipse?
An ellipse is determined by two focal points, foci, and the focal constant. That's the constant sum of the distances from any point on the ellipse to the foci.
Major axis. This contains the foci and it is always longer than the minor axis.
Minor axis. This is the short one. Actually, there's a special kind of ellipse that kind of breaks this rule a little bit, so hold on and watch later. What's the equation for the ellipse?
An ellipse with foci c0 and negative c0 and focal constant 2a has equation x squared over a squared plus y squared over b squared equals 1, where b squared equals a squared minus c squared. In the ellipse with this equation, 2a is the length of the horizontal axis and 2b is the length of the vertical axis.
This is our example. This is the equation. This is the standard form equation, so you can get 64 equals a squared as shown here, and 25 equals b squared shown here. If you solve it, you will get plus or minus 8 for a and plus or minus 5 for b.
One really important thing that you always need to remember is that length can never be negative. So although when you solve the equation you will get plus or minus 8 and plus or minus 5, your actual answer will be positive 8 and positive 5 units.
You can find the intercepts by plugging in 0 for one of the x or y's. This will help you graph the equation.
This is the graphed ellipse.
You can see how the x and y intercepts are related to the equation. What are ellipses?
Thought you'd never ask. They are cool ovals with two focal points.
It has two axes,
a major and minor.
b squared equals a squared minus c squared. Oh!
Ellipses, ellipses, ellipses are cool. Ellipses make me not want to die when I'm at school. Aye! Ellipses, ellipses, ellipses are cool. Ellipses make me not want to die when I'm at school. Aye!
And that was our song
about ellipses.
Goodbye.
Circles.
Every circle is an ellipse, but not every ellipse is a circle.
A circle occurs when the major and minor axes are equal.
To get the area of an ellipse, you multiply pi AB.
Now the equation may sound a little familiar because A, B are your major and minor axes, which basically means they're your radius, which is the same as the equation for the area of a circle, pi r squared. Disclaimer. Pi r squared is not going to work for every ellipse because A and B have to be equal and they're only equal in a circle.
So using A and B, you can find the area, and in this case, it's 40 pi units squared. For a circle, you'll use the equation pi r squared, and by doing this, you get 25 pi units squared.
Ellipses can be thought of as stretched circles. The transformation of the stretching is called scale change.
This can be written with the letter S. For example, you can write scale change 3, 4. Multiply the x and y intercepts by 3, 4 to get the new ellipse.
An ellipse with endpoints 1, 0, 0, 1, negative 1, 0, and 0, negative 1 would end up like this. Scale change 3, 4, 1, 0, 3, 0. Scale change 3, 4, 0, 1, 0, 4. Scale change 3, 4, negative 1, 0, negative 3, 4. Scale change 3, 4, 0, negative 1, 0, negative 4. Let's get down to business to learn some math.
A circle's just an ellipse with equal axes.
Ellipses are not circles, it's the other way around.
Mister, I'll show you to learn. Ellipses can transform. It's called scale change.
You can see it when a circle's stretched.
You can see a giant S in two subscript numbers.
Mister, I'll show you to learn. Let us learn.
Circles are special ellipses.
Let us learn.
'Cause their A and B are equal.
Let us learn.
And you can find the area.
Let us learn.
The area is pi
AB.
And that was our song.
About ellipses and circles.